All right, let's go ahead and get started. We really need to just kind of finish up this topic on branches and looking at just a little bit beyond just the typical if followed by else. You can always combine these ifs and elses together in these so-called what we refer to as nested or chain blocks of code. In C, unlike some other programming languages, there isn't a separate else-if construct. There could have been, but there just isn't by design. You can basically implement an else-if construct with just a little bit of clever formatting. And to be honest, the formatting works well enough that you really don't have to think about this after the first time you've ever tried and implemented this, which is you have your if statement, and then there's an else associated with that if, right? The false side of the branch that we're taking here. And you can use the fact that you can have effectively a one-line body of your if statement, like we talked about, that does not require any curly braces, to then start to implement a whole other if statement inside that else block here. And that's actually all that's happening here. It's really more of like a white space trick than anything else, but it's also kind of the standard appropriate way to implement what other languages provide as ELSIF as like a separate syntactical construct here. So logically, and in terms of how we read out what's happening in this code, it does what I think one would hope it does. And while it may not be that great a use of your time to kind of draw out these control and data flow graphs for every set of if statements you write in your code, you at least need to be aware that there always is that equivalence, right? That given an if, that's our little diamond in the little diagram here, given our if, that splits our code path in two. If v1 is less than 47, we're going to then do something. The remainder of that else corresponds to that if statement and encapsulates the rest of this code here. So in fact, if that if statement gets taken, we do whatever that next line is, v2 equals v1, and then we're done with that whole block of code until the else corresponding to that if is done. In this case, that else is now encapsulating its own if statement. That now becomes that whole right-hand side of the control and data flow graph here. Else, big old complex if statement, which includes an if, as well as an additional if, which has its own else, as well as an else corresponding to that if. This could be in theory interpreted as being one or more different ways of doing control flow. In practice, it is just one. It corresponds directly to that diagram on the right here. It is possible to mess this up in your first couple of attempts. My guidance for you as you work on this would be, if it starts to become really hard to understand what you're doing here, there's very likely an opportunity to simplify the logic that you have. It could be then, let's instead use maybe some of those Boolean operators instead of just if after if after if after if in my code. But sometimes you do need something that looks kind of like this. Otherwise, you really do want to follow that code formatting suggestions like I have it here, like Replit will give you when you press the format code button in the editor there, because it is important, I think, at least for me, I find it important, to have a good kind of structural layout of the code to allow myself personally to be able to visualize where my code, what paths it's potentially taking here. And then otherwise, my advice is just like anything else. Add debug statements to convince yourself that for a given input, we're progressing as we hope, as we are through the code. Before the if statement gets entered, print out your variables. After we're done with all this complex if statement, print out your variables, the ones of interest for your code. And when you don't get what you expect, that is a bug and there's no magic to it, but then just kind of go line by line and say, okay, am I getting into this if statement the way I think I am? Am I actually having an else that is actually connected to a different if than I think it's connected to? There is no real shortcut other than thinking through it. Formatting it will help you, syntactically formatting it properly will help you, and then recognizing that, this isn't too bad, but if you really have a spaghetti of if and else's inside your code, take a step back and say, do I really need all that? Or am I just increasing the likelihood for bugs? But there's other constructs we can use which can oftentimes help. A very common code pattern that we have when we're trying to solve things is scenarios in which we'll want to check the same variable over and over again. This example on the previous slide arguably is like that because it's checking V1 on 2 occasions, but it's checking V2 on the 3rd occasion. But it's pretty common to want to check a single variable over and over again. For example, if V1 equals 1, do something. If V1 equals 2, do something else. If it equals 3, do something else, etc. And that's why we have this so-called switch statement in C. That's exactly for these kind of scenarios. It's never strictly required in your program. You never have to use a switch. But instead of creating several if statements over and over and over in your code, or even worse, if, else if, else if, else if, else if in your code and nesting that all the way down, we switch on the value of a variable and choose one of several outcomes based on the value of the variable. You may not have much experience with dip switches, but that's what we're really thinking of, not like a light switch, which is just an on-off. So an if statement is closer to a light switch. This is more a dip switch where we're kind of independently checking the value of is 1 on, is 2 on, is 3 on, etc. You can only switch on integer values. That's just a shortcoming of C. If you have a string, you can't switch on a string. If you have a floating point value, you can't switch on a floating point value. I would argue the syntax is also just a little bit messy. The first couple of times, just have this reference open or some other reference open so that you can look at the syntax and just remember exactly what you want to do here. And then the 3 new keywords this introduces are switch as a keyword on a variable, an integer variable that we're checking, we're deciding based on. We then use case as a new keyword here that be an integer or character saying, here is the value of that particular input variable that we are interested in. So switch, we put the whole switch statement in our curly braces, case, value of the case statement, and then a colon afterwards, and then break statement afterwards, which we'll see in a couple of different contexts eventually. Break signifies don't continue inside this switch statement. We're done. We are done with this set of curly braces is what effectively break, and we'll use it in a couple of other places as well later on. Don't continue with this switch statement anymore. We checked the value of input. It happened to be 10. I have just a little comment here that says do something interesting, because whatever we want to do when the value of input is equal to 10, and then be done. Be done with the case statement. The other syntactical thing we're adding here for switch is the default keyword. That is, for all other values that we did not enumerate through these case statements, do something for those other circumstances. I would say do something interesting for all other integer values. And we generally want to have that in our program. We can't enumerate all the values. I guess for a car variable that has 255 possibilities, you could write a switch statement that had 255 case statements inside it. There may be some circumstances where that makes some sense, maybe. But for any other integer, that's not feasible. Even for a 16-bit short integer, you would need to have 64,000 case statements inside your switch. That'd be a very long block of code. So in general, we use our switch statement when we have an integer variable, and there's, say, a dozen different things we want to do based on the value of that variable, just for a round number there. We would have 12 case statements in that circumstance. And then for all other values of that variable, we may want to do something else, or we may want to catch an assumption that maybe was wrong, that, hey, I wrote this code, and I know the value of input is always going to be 1, 10, or 15. I'm a programmer. I wrote this program. I know it's always going to be 1, 10, or 15. Well, then what should we put inside this default statement? What do you suggest? What would you, that's correct, printf, what would you print? So printing the value is always good, like a debugging statement. In this circumstance where I said, hey, I know it's always going to be 1, 10, or 15, well, what do we say about assumptions, right? It wasn't 1, 10, or 15, otherwise it would never have reached this statement. To me, that's a bug or an error or an exception, something we have to raise and say, by the way, input value is 99. Something has gone wrong, right? Do something or be aware as the person executing this program that we have an issue, that an assumption we had was wrong. There's a bug somewhere else in the program. Something is going to happen that was not expected. That is a pretty common use for that kind of default case here, kind of error handling, that you state all your reasonable assumptions of what you expect the input to be for that integer variable, and you have reason to believe that if it ever gets there to that default block, something else has happened. There's some other bug along the way. So I mentioned point 1 already, only for those integer variables. For better or for worse, that's a limitation. You can include any valid C code once inside that case. We have that break statement. And while we oftentimes, again, associate break with the switch statement, what break does is it's a short circuit. Transfer, like circuit breaker, transfer control outside this curly brace. Go here, basically, is what that break statement is doing. Technically, and there's some circumstances, we'll do a circumstance today that allows for this. Technically, you don't have to have that break statement. If you don't have that break statement, the program will just continue on to whatever the next line in your code is. So for instance, if I didn't have this break statement right here, you can see that mouse cursor, right? That code is not necessarily wrong. It's a smell that like maybe that's a bug you have, but it's not necessarily a bug. All that would then mean is, let's say the value of input was 10. You would do both something interesting for when the value is 10, as well as something interesting for when the value is 15. If there was no break statement here, it would just continue. Sometimes we may want to do that. If the value is 10 or the value is 15, do something. Or if the value is 10, do both the thing for 10 as well as the thing for 15. If you have enough of those weird kind of non-traditional usages, maybe an if statement makes more sense than a case statement, but it depends. So it's not necessarily a bug. And I guess I mentioned this more explicitly on the slide. You may want to have, for multiple values of the input integer, the same identical functionality. It is good programming practice, as I also just mentioned, to have that default case in all your switch statements. So for now, since we're never enumerating all the possibilities, and your compiler will give you a warning if you don't have it for that reason, you should expect whatever case statements for values you expect to be there, and then you should do something for values you aren't expecting to have there. Again, this doesn't always have to be an error checking kind of code. It could be something really specific I want to do for those 3 values, and something more generic for all those other non-enumerated values. So not necessarily an error, but we should be checking that that is the case here. No pun intended. So a very short problem-solving exercise where our input, in fact, really for this problem-solving exercise, all the parameters are given. I don't think we have to kind of dig too much deeper. We can just program it up. Input is an integer representing a day of the week, and the output is a printout if the day corresponds to a weekday or a weekend or the weekend. So if the input is 5, we would assume that's Thursday, Sunday, Monday, Tuesday, Wednesday, Thursday. That sounds good to me. And today is a weekday is what the program should print out. And it should output invalid day if the input is something outside of that range 1 to 7. So 0 is invalid, -46 would be invalid, and the program should just output invalid day if the input is something outside of that range. And let's just do it together versus breaking up into groups. Let's solve the problem both ways. Let's use, I said nested if statements. Let's use just a simple if statement with the Boolean operators. That seems appropriate to me for this problem. And then let's look at the syntax for the switch statement and do that as well. Input is an integer. Output is just a printout. So we should have the ability to handle that. Again, for this one, and we'll do this in Replit under 305 called labeled weekday. There really isn't that much deeper work we have to do, right? You could copy paste, I guess, the spec into the code. Input's an integer, output is a printout. So we do know that we need an input variable. Day sounds good to me. I like my printf, scanf prompts, right? So enter in an integer in the range 1 to 7. What should the next line of code be? Awesome. And day, thank you. It was letting me know that that was a mistake there. And I trust our coding skill. We don't need to do a printout to confirm that that was what we entered in. Printf prompt gives us a nice little prompt, a scanf with an integer value. We use that ampersand symbol because that's storing the address of day, and that's going to get overwritten. With a so-called simple if statement, just tab back real quickly. If the input is 5, that's a Thursday, that's a weekday. Okay, so there is a little bit of problem solving here. If input is, thank you, 2, we'll say 2 through 6, we'll write it out. 6 should print out, we want to say today is a weekday. Input is what for week? You got it. Today is the weekend, thank you. Otherwise, which else, right, should print out invalid day. Okay, so there's a little bit of problem solving. Perfectly valid to, like, put that as little comments in your code. You can delete them later if you want to. You don't have to. By the way, that was the only, in my opinion, only bad question on Wednesday's quiz. Only silly question on Wednesday's quiz. It was worth 1 point out of 25, which was the multi-line comment, which we hadn't been doing a lot of them. It was in the Replit, in the Zybooks book quite a bit, which was there's just gonna be problems with these with comments. Other comments inside comment wouldn't work because this would close that multi-line comment, and then this one doesn't get gets improperly closed. So that would be a syntax error. And not only was that a not great question, that was the very first question on the quiz. So it's 1 point. We'll be fine. And I believe everybody got that 1 point wrong. So that's a good sign. It's a bad question. My bad. 1 point. We'll be fine. If everyone wants that point back, that's fine. But everyone gets that point, so it doesn't really count for anything. Okay. So if statement. Input is 2 through 6. Should print out today is a weekday. If we want to refine that further, we can. I don't think we have to write more comments about that. If the input is 2 through 6, think the challenge is, converting that to code. That's what programming really ultimately is, right? From spec to kind of English to code. If the input is 2 through 6, somebody else help me out. What would that look like as an if statement? Sure.
If day is less than 6 and greater than 2.
Yeah, I'm surprised you did it in that order. That's fine. Yeah, if day is greater than or equal to 2, we talked about like using parentheses so you don't get messed up with any order of operations. Awesome. Print out. Printf, today is a weekday. Put an unnecessary new line. Okay. Else, otherwise, right? Technically. And this is, more philosophy than technically we don't need else if here. We'll do it because we're not changing the value of day. So if and else if are going to kind of work exactly the same. I don't want to belabor the point, but else if is based on what we were talking about is the right way to do it. If the input is 1 or 7, what would that look like in terms of an if statement then?
Day is equal to 1. And then double play.
Yeah, you can just say or. We got you. Day equals 7. Otherwise, else. Well,
That way it should there's the weekend isn't touching
the prompt.
number that you insert.
Well, so the funny thing about scanf usually is you usually don't want to do scanf with like a new line or even printing it beforehand. Because when you enter that in, usually with scanf for integers, you have to actually provide the new line to tell it that you've given it an integer. So it looks pretty, yeah, and that would be the case for non-character inputs here. Scanf is going to go until it knows it's read an integer. Well, how does it know it's read an integer? If you look at the implementation, it waits for a new line character. So you kind of get a built-in new line character, for that reason. And that was pretty good testing. Truly to test this, we should test a bunch of different values, right? Okay, seems like it's working reasonably well there. This is the quote unquote correct way to do it, right? So logically connecting those series of statements. If you had done this differently in terms of you wanted to check invalid first, that's perfectly reasonable way to approach it as well. But the way we spec this out, if the day is in that range, and we have those relational operators, as well as then the Boolean operator to check that is within a range. So both things have to be true for it to be in the range 2 through 6. It has to be both greater than or equal to 2 and less than or equal to 6. You could have done less than 7, because we know it's an integer value. You'll get the same result back out. But logically, this is a really great way to do it. And then this else if, we have to be a little bit careful, right? So I had mentioned how here the else, and this is a little bit of syntactical fun here, that else is a single line if statement that connects this whole block as now the else side of that initial if statement. This is now a bug. Let's take a moment, read what we changed. I just got rid of the word else. We walk through it and it seems okay. I enter in a value of 1. Today's the weekend. And I move on. I submit my code and I move on, and I don't think about it any further. First if statement. If day is greater than or equal to 2, day is less than or equal to 6, today is the weekday. We're done with that if statement. We proceed to here. We're on line 16 effectively. If statement here. If day equals 1, day equals 7, today is the weekend. This else is associated now with this if statement. So when I enter in 2, what is it going to print out? That's a bug. You will make this mistake. Don't sweat it when it happens. It's the else is now not associated with the if statement you think it is. And yes, technically, I'd want you to kind of draw, let's go back. I'd want you to draw this out to some extent and convince yourself that that's the case for the if statement you have created. In practice, you come to my office hours, and you're very welcome to come today. I would just kind of show you that that was the case. Formatting the code properly helps to catch this. It has nothing to do with the white space. I can have 50 lines of white space here, and it doesn't change the fact that that else is now affiliated or associated with that initial if statement. It's about where we put the else related to that if statement, allowing this final else to be associated with it. Another approach, I'm gonna comment this out real quick. I'm going to add a third approach that I didn't mention, because I already said that given the way this problem is scoped, in which the variable itself is not changing, it's a nice little editor feature. If you have a multi-line comment, you can just fold in that code and then you don't have to look at it again, at least temporarily. Would be to not use else at all, would be a valid way to do this. If you're not going to use else at all, then the ifs don't have to be associated with each other. This only works if the value of the variable you're checking is not going to change in between these if statements. And then we have to refactor it a little bit. If day is greater than or equal to 2 and less than or equal to 6, today's the weekday. If, second condition. Now we would just need to add a third condition for invalid day. What would that look like? Yeah, or is correct there. If either of those are true, it's less than 0, or less than, or the way we've written this, less than or equal to 0. Wait. Well, let's be consistent here. Okay, less than 1 or greater than 7 here, right? 1 is valid, 7 is valid, 0 and 8 are invalid. If we did less than or equal to 0 or greater than or equal to 8, that would have been fine too. This is also a perfectly fine way to do it. And don't let anyone tell you that this way is better or worse than the previous method. They're fine. They're equivalent to each other. This allows us to logically walk through the permutations of what is possible here, and we get the results we expect from it. Different ways of thinking about how to solve the same problem. Not right or wrong, just different ways of using if statements. We also could have done the chained if statement where there was if day is greater than or equal to, then inside that if day is less than or equal to 6, then print it out. That's fine too. To me, there's very clear logic for what we're checking here, like with the word and kind of implied or implied. So connecting that to Boolean logic in the program seems like the natural way to do it. But how exactly you structure your if and else statements, it's kind of up to you. As long as you can debug it, it's generally going to be okay. But now we then also have this way of doing a switch statement here, for which the nice thing about this problem is there's only 7 valid possibilities. So if it was 2,000 valid possibilities, then switch isn't going to make sense. But in this case, there's 7. That seems reasonable to do a switch. We're switching based on the value of day, and we only have so many possibilities. They don't have to be enumerated in order. Case 1, today is a weekday. I mentioned that break statement, and there we go. We could then say, okay, that's also the case for case 7. Except that's wrong. You guys are supposed to catch that. Today is the weekend. Close enough. You can do it in order. It's fine. Case 1, today is the weekend. Also, case 7, today is the weekend. You don't have to do them in any order. So I could have put 7 before 1, or 1 and 7 kind of logically next to each other. The other thing that probably makes sense is in this circumstance, as I mentioned as a possibility for the switch statements, we want to do the same exact thing for both case 1 as well as case 7. So for me, I think it makes perfectly reasonable sense to combine those two case statements together without a break statement between them. Case 1, we continue on. Case 7, we continue on. We print out today's the weekend. Then consequently, we would want to do the same for those middle cases. Today's a weekday. And only then do we break out. And then that's our else, right? That's our for all other possibilities. There's our invalid day. You don't technically need the break because we're done with it, but it's good practice you have it there. Questions about the switch example or about any of this code? Nope, unfortunately. We will see that in general, we've already seen it a little tiny bit, that due to the nature of how we use this floating point format to represent fractional values, checking for equality in general with floats is actually kind of risky, because it turns out you can check if something's equal to 22.5, but checking if it's equal to 22.7 may not work in your code, because we can represent certain things precisely and other things only approximately, because there's an infinite number of fractional values and we only have the 32 bits to shoehorn into that. Whereas with ints, if it's within range, it always can be equal or not. With floats, there's always a little bit of compromise. So it doesn't really make sense to have a switch on a float. What other languages allow you to do is to switch on a string, for example, which would be very nice, but you can't do that in C.
But you'd also be able to use characters then too?
Yeah, because the way the character is ultimately represented, in fact, in this case, it would probably work anyway, default, because it's a small little integer, right?
Yeah.
That's a fun little error message. Stack smashing detected, terminated. We're going to leave that for another time. I mean, I know what it's getting at, but why is it giving me that error is interesting. Because it's reading more data. I got to think about that a little bit. That error is in, or that message is coming in scanf. That's interesting. Okay. Anyway, it'll work for characters as well. So if you have character types and you want to check if it's A, do something. If it's B, do something. That will work. You could put, you can use the numeric value from the ASCII table, or you can do the actual character inside the switch statement. I'll leave it to a weekend post about what stack smashing is about. We'll get there.
Is there certain like reasons to go with case versus an else statement, like for application wise?
Well, and you know, if we compare these two code blocks, I think it's more of like a personal preference. You know, which one is better? I don't know. Hard to say. In the extreme, we can always determine that, right? If there is 2,000 values, this is never going to be good to have to enumerate all those different values. But in this case, there's really only 3 possibilities. So 3 if statements isn't that bad either, right? Like we had it there. Code that you can read, that you can test, that you can debug is the right code to write. So it's hard to say. You know, I won't give even a personal opinion about which one's better. They're just different ways of doing it. Not in C, yeah. So you could argue that that's kind of the only ugly part of this code that the way we had it. If we had a program where there was clearly something we wanted to do for all, today is Monday, today is Tuesday, today is Wednesday, if that was the program spec, then in my opinion, the switch statement looks a lot better, probably. If it was clearly 7 different printfs for 7 different values, switch is perfect. Here there's only 3 different possibilities. So both examples are pretty good. There are a couple other control structures that we will learn. Break in the context of loops, which we're going to talk about loops for a few minutes today, is also can be thought of as a different type of control construct. Continue in the context of loops. Return in the context of functions. While we do have returns, we're not really using them yet. That's also another way of doing control flow in your programs. But another fun one is if, for example, you had a deeply nested set of if statements and there's only one condition that would require the program to kind of skip the rest of the entire block, you would either have to create all sorts of additional ifs at each level that checks for the condition and skips that level, or you can use this additional construct referred to as goto to actually go to a labeled block of code in your program. I am introducing this here just for a little bit of fun. It is very uncommon to see goto statements in programs anymore. It's a very low-level thing, right? It's literally transferring control arbitrarily in your program from one line of code to another arbitrarily selected line of code. Makes it very hard to read, very hard to really understand exactly what's happening here. And it's a bit controversial. It's essentially an assembly instruction to say jump to this location. And in terms of if this was a class that was in computer science, there'd be some theory we'd read about why it's never strictly necessary. This is one of the more famous papers in computer science of all time. The title's "Goto Statement Considered Harmful." If you know who Edgar Dijkstra is. I bring this up here because then if you look at, although it's not in the kernel schedule or code for Linux kernel anymore, but the comment was Dijkstra probably hates me because it was just littered with goto statements to actually get the code to work. So it's there. It's just another valid piece of C that you can literally go to from one line to another. I don't think we necessarily will need to use it, but it's there for us. So what I would like us then to do, if that's okay, is to do a pretty quick context switch into the next topic I want us to talk about. We'll do so in more detail next week as well. But so that's all of topic 3, which is if statements. I want to talk about loops next. It's kind of the obvious next thing to talk about after if statements in C. So the other title for this is repetition structures. Very soon, as you finish up Lab 3, you're going to have Lab 4, and then RA4, and CPO4 related to this topic. I think the nice thing about covering this topic, arguably we really want the next topic as well, which is arrays, because they are very closely related once we get there. So topic 4, as well as then to some extent topic 5, we're kind of ready to go in terms of our programs will still be toy programs. We only have so much time to write programs in class together, but we're kind of ready to go in terms of writing more advanced things once we have these 2 topics. So for those of you who maybe felt like we're just kind of going too slowly here, we're still going to go slowly in terms of content, but the type of programs I'm going to expect you to be able to kind of work your way through, it's still just going to be a combination of what we have. It's always variables. It's always arithmetic on those variables. It's always if statements based on the value of those variables, and now it's going to be looping based on those variables. We're going to add in arrays because that does make the code a lot cleaner and easier to write for more advanced things. But after that, that's what all of our programs are always going to have. And the rest are just going to be advanced features that you certainly really never technically need in your programming. So loops are important, and let's motivate why loops are important. Think we've seen why we needed if statements, maybe to a lesser extent why we need switch statements, but we need control structures. The example from actually last week was sorting 5 numbers. I didn't show this illustration last week, but this is basically what we did with, if you recall, var1, var2, var3, var4, var5, and just working our way through those 5 variables and swapping them, swapping 1 versus 2, 2 versus 3, 3 versus 4, 4 versus 5, and then doing it several times to get our array sorted. Why I didn't bring up this visualization last week, I don't know, but here it is now. This is how we sorted those 5 values. And the code worked. I think we saw maybe the limitation of that code as well, even though the code itself worked. First off, do we really need a computer to sort 5 numbers, right? Do we really need to write a program in practice to sort 5 numbers? What if we did briefly touch upon this, what if instead we have 5 million numbers and not 5 numbers? Does the basic task change significantly? In terms of the task, the answer is no. In terms of the program we wrote last week with our if statements, the answer is yes, right? The program goes from tractable / feasible with 5 numbers to completely intractable to put together if it was 5 million numbers, just in terms of the amount of copy paste we'd have to do, the amount of lines of code to even get one pass through a list of 5 million numbers. That's our motivation for this concept of looping structures. Computers were originally invented to automate tasks, right? The whole idea of having a computer is to automate tasks that were either too time-intensive or too error-prone when done by hand. The whole point then is to have more than a small number of operations inside our program. We can encode more and more operations just by having more and more lines of code in our program, but there's a limit to it, right? We can have complicated programs. There are applications out there that have millions of lines of code in total, but in general, for any one given application or one given operation, we're limited in terms of the lines of code we want to be able to write and to maintain. So most programs in practice, even if in theory it's not strictly needed, have control / data flow graphs that repeat some operations a finite number of times depending on some particular condition. So they tend to have a structure that at some way, shape, or form has a feedback loop or has an arrow going back to some earlier point that loops around. We talk about repetition structures, we talk about loops. That's what I want you to think about. At first blush, it looks very similar to the if statement. And syntactically, it's also very similar to the if statement. It's just a different keyword we're going to be using here. But in practice, what that allows us to do is to encode some singular operation we're interested in, and that singular operation could be, let's say, this, and then to choose to just do this multiple times. to repeat that set of code multiple times. I put these historical figures and try to be funny, but then I realized nobody knows who any of these historical figures are. Let's leave them all as bonus credit. If you can, but I guess reverse image search is very easy these days, so it's not that much of a challenge. Okay, 1833 computer organization. See if you can find. Okay, yeah, you got it already. Charles Babbage, thank you. Awesome. And he's right, by the way. I made up. That's not a real quote. He's obviously been dead for hundreds of years, but he's right. Also, computer architecture really hasn't changed that much since the difference engine that him and Ada Lovelace created, because that was the whole point of that computer, and that's the whole point of computers today. They use a lot of transistors, but they're doing basically the same exact thing. Things haven't really changed. So the simplest repetition structure, or the simplest loop, is the while loop. Other programming courses I've noticed introduce the for loop first, but I think if we actually understand the while loop properly, the for loop is just a special case of the while loop, and I think that's the correct way to do it. There are three main components of the loop, of the while loop. There needs to be an expression that initializes a loop control variable. That's a very formal sounding kind of thing. But just like we have variables inside our if statement that we're checking, this is the variable that we are checking inside our while loop here. So in this example, A is the loop control variable. It doesn't have to be declared immediately before the loop. This could be 100 lines of code beforehand. Oftentimes we want to set it at least soon before the loop itself. You want to be able to look at the block of code and know what's going on. Int A equals 1. That's the first component. Then there's the loop repetition, which usually would involve another one of those relational operators. So it should look a lot like an if statement. Instead of if A is less than 3, we now have while A is less than 3. And in general, you just want to read it out loud like that. While A is less than 3, do that. Do whatever inside the loop body here. Syntactically, though, should look just like the if statement, just with the while keyword instead. And that now implies not a single choice we're making, but multiple choices we're making. And then the third thing we have to have, the if statement could have anything inside its loop body. The while loop can also have anything inside its body here, but we generally need to have some mechanism to update that same variable inside the while loop. We have to have a way to get out of the while loop, to set the value of A so that eventually this condition, which may be true in the beginning, is no longer true at some point in the future, so that we get inside the loop, execute it a certain number of times, and then eventually get outside the loop. Otherwise, it's the same exact syntax as our if statement. Purposely very similar. So instead of if some value is true, then do something, and that's how you read it out. It should be while some value is true, then do something. And that's not to say you can certainly have if statements inside your while loops. You can have while loops inside your if statements. It depends on what you need to do in your program. If implies there's a single decision being made at some point in time. While is there for repeating. You're going to do something multiple times. Visually, once you have that while loop, I want you to think about that loop, that like data flow loop of we're going to keep checking it over and over and over again. This is going to lead to an additional new class of bug. While, again, syntactically, this isn't all that new. There's going to be a new class of bug due to component 3 here. An expression that updates the loop control variable. Again, how have we been writing our programs? We've been scaffolding them as we go, right? Write a little bit, test, write a little bit more, test, write a little bit more, finally test the whole thing. With loops, you have to be a little bit more careful. Let's say I wanted to check if while A is less than 3 is correct for my code, and I was going to add all this stuff later. Sounds reasonable. What would be the problem with our program? I know you've got it, somebody else. If I didn't have this here, what would be the problem with this while loop? It would never end. It's what we refer to as an infinite loop. Generally, that's a bug in our program. Not 100% of the time. Sometimes we want to write a program that gets to a loop and never ever leaves that loop. It's an industrial control application, and as long as the machine's powered on, we should be inside that loop. Well, that's fine. But for the most part, certainly for the programs we write this semester, where you need to be able to submit it and turn it in and have the program finish, an infinite loop would be a bug. And if we're not careful, if we didn't update this at all or didn't update it properly, didn't really think all the way through about what does the value of A need to be for us to be inside this loop, what does the value of A eventually need to be for us to get outside this loop, we would run into that kind of problem. If you had a printf inside the loop, not a big deal. You'll catch it. That printf is just printing, 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 printing. If you didn't have a printf inside the loop, things would just look kind of stuck or broken, right? Code would be executing, nothing would be happening. When you see that happens, you hit the run button in Replit and nothing is happening, and you may say, I have no infinite loop in my code, you're wrong. You probably do, and you just don't see it yet. We'll find it together. So what does this program do? We can run it. I mean, that's always a valid way to answer a question. We can run it when Replit boots up here. Okay. Let's walk through it. So it's a variable for an input, as well, and then yeah, go ahead, sure. Awesome. So it's going to keep reading and prompting into read in integers until the sum of all the integers that have been read in is greater than or equal to 100. Enter in 50, enter in 49, and greater than or equal to 100, enter in 1, and the sum is 100. Okay. And it does have all three of those components. There's other variables, or again, there's other stuff going on here. Our loop control variable, our while syntax, and then some mechanism by which we've updated that loop control variable inside that loop. Awesome. We have time for one more. What does this code do? Okay, fine. You're right. We have a program in front of us. Let's just run it. What? Why guess, right? Hey, what does this program do? Just hit the run button. It'll tell you what it does. Oh, no. It's a crazy stairs program. Let's take a look at it here. Loop control variable is now A. We initialize it to 1. While A is not equal to 20, increment a sum again, a running sum of A, and add 2 to A as it goes. If I wanted to add a debugging statement to this program, what would be a good debugging statement? So by the way, I have a bug, right? At least I would say that. I hit the run button and things are stuck. Don't panic, okay? You've hit run and nothing is happening. Hit stop eventually. Your thought process should be, I have an infinite loop. I may not think I do, but I very likely have an infinite loop. The most useful variable probably to print out would be that loop control variable. And again, this is kind of a temporary printf that you're adding for your own internal testing purposes. There's some fun things you can say, like you can print out the line of sometimes I say, I've reached this line, reached this line, reached here. Sometimes you just print out here to convince yourself you actually got to a spot. I know we got to go. And you'll notice it looks like it's stuck, but it's actually just printing over and over again. You can actually also print out the line of code that you're on. Reach line 7. In our purposes, maybe just getting the value. A is this, and we don't want to print out the line number anymore. Let's print out A. And you get to see how fast computers are these days. Computers are a lot faster than that. What is slow is printing is still quite slow. So if we weren't printing, it'd be incrementing A significantly faster than what we're seeing here. Let's leave things here with our infinite loop for today. We'll pick up right here on Monday, kind of debug it. It's a toy example, so there really isn't any fixing it, but recognizing what happened is what's important.